Disposal of radioactive waste in India. Radioactive waste arises from the civilian nuclear activities as well as from the defense-related nuclear weapon activities. Radioactive waste poses a formidable problem for handling and protecting the environment. It is important because it has to be safe to the present and future generations. As nuclear power and arsenals grow, continuous monitoring and immobilization of the waste over several decades and centuries and their deposition in safe repositories has become a matter of great relevance and importance for the country. Just as per capita consumption of electricity is related to the standard of living in a country, the electricity generation by nuclear means can be regarded as a minimum measure of radioactive waste that is generated by a country. Therefore, there is a related magnitude of the radioactive waste management. On the scale of nuclear share of electricity generation, India ranks 4th from the bottom in about 30 countries. So it's not a big magnitude at present. Therefore, the magnitude of the radioactive waste management in India could be very minuscule as compared to that in other developed countries. It is especially so when one takes into account the nuclear arsenal that are already in stockpile in the nuclear weapon countries. Radioactive waste management has been an integral part of the entire nuclear fuel cycle in India. Concern for the environment and establishment of radiation protection goals have been the major priorities in planning India's nuclear energy program. In the Indian nuclear fuel cycle, right from inception, there is what is called a closed loop option that has been adopted. In this, the spent fuel is reprocessed to recover plutonium and unused uranium. The emphasis has been to recover actinides, individual fission products, and recycle them back to the fuel cycle or use them for various industrial applications. The development of innovative treatment processes for lower and intermediate level waste in recent times has focused on volume reduction as one of the main objectives. In the case of high level liquid waste, vitrification in borosilicate matrix is being practiced and it is being used as induction heated metallic melters at industrial scale plants, that is in Tarapur and Trombay. Let us understand some details about the nature and generation of radioactive waste in India. Radioactive wastes are generated, as said earlier, during the various operations of the nuclear fuel cycle. Mining, nuclear power generation, and various processes in the industry, defense, medicine, and scientific research, they produce byproducts that would include radioactive waste. This radioactive waste can remain radioactive for a few hours or several months or even hundreds and thousands of years. That is the complication of the radioactive waste. Therefore, there are many categories of radioactive waste and there is a classification. Depending on the level and nature of radioactivity, radioactive waste can be classified as exempt waste, low and intermediate level waste, and high level waste. Now let us see the low and intermediate level waste. The low level nuclear waste usually includes the materials that are used to handle the highly radioactive parts of the nuclear reactors, that is cooling water pipes and radiation suits, and also the waste from medical procedures that involve radioactive treatments or X-rays. As regards high-level radioactive waste, high-level radioactive liquid waste contain 99% of the radioactivity in the entire fuel cycle, and it is produced during the processing of the spent fuel. The issue of long-lived radioactive waste has been the focus point of debate for the scientists to be successful for the nuclear power generation. Planning for management of high-level waste, therefore, has taken into account the need for their effective isolation from the biosphere and their continuous surveillance for extended periods of time, and it could be spanning several generations. To meet this objective in the long term, waste isolation systems comprising multiple barriers have been employed so as to prevent the movement of radionuclides back to the human environment. So how are you managing the radioactive waste? In consideration to the primary objectives of protecting a human health and environment and for the future generation, the overall philosophy for safe management of radioactive waste in India is said to be based on concept of delay and delay, dilute and disperse, concentrate and contain. Effective management therefore involves the segregation, characterization, handling, treatment, conditioning and monitoring prior to the final disposal. Proper disposal therefore is essential to ensure protection of the health and safety of public and quality of the environment, that includes air, soil and water supplies. Radiological hazards associated with a short-lived waste that lasts for less than 30 years, half-life gets significantly reduced over a few hundred years by radioactive decay. The high-level waste contain large concentration of both short and long-lived radionuclides that warrant a high degree of isolation from the biosphere, and it usually calls for a final disposal into geological formation. The key idea in this was that the long-term disposal would be best carried out by identifying a suitable sites at which the waste could be buried under a process called deep geological disposal. As regards low-level waste, it is comparatively easy to dispose of. The level of radioactivity and the half-life of the radioactive isotopes in low-level waste are relatively small. Storing the waste for a period of 10 to 50 years therefore will allow most of the radioactive isotopes in a low-level waste to decay, and at this point the waste can be disposed of as a normal refuse. In solid waste, substantial amount of low-level waste of a diverse nature gets generated in different nuclear installations. Treatment and conditioning of solid waste are therefore practiced, and they reduce the waste volumes in ways which are compatible in minimizing the mobility of the contained radioactive materials. A wide range of treatment and conditioning processes are available today, and they are mature industrial operations, and they involve several interrelated steps and diverse technologies. A brief summary of the various radioactive waste management in practice that is followed in India is diagrammatically shown in this diagram.